Today while I'm out, you're going to solve right triangles. That means you need to know all three angles in the right triangle, and you need to know all three sides in the right triangle before you've completed the problem. Now, every right triangle, one of the angles is a right angle, so you only have to find the two acute angles. There are two methods. The two methods are, one, use the postulate that states that the acute angles of a right triangle are complementary. So we're going to subtract the acute angle from 90. So in order to use that one, I have to be given an angle. If the problem doesn't give me an angle, then I can't use this method. The second way is to use the inverse trigonometric ratios to solve for the angle. That would be sine, cosine, or tangent. I use this one when I'm not given an angle. Once we know the angles, then we can find the sides. We have two ways that we know to find sides. We can use the Pythagorean theorem to find the missing side. To do that, I must be given two sides because I can only solve for one unknown. So to use the Pythagorean theorem, I must be given two sides. The second way that we found sides was using the trigonometric ratios to solve for sine, or the sides. The trigonometric ratios are sine, cosine, or tangent. Remember, you're going to use whichever one gives you the correct proportion to compare the correct sides and set up a proportion. So you use the trigonometric ratios if you're only given one side. Now let's look at a couple of examples. In the first example, I notice that I'm not given any angles, and I'm going to try to find the angles first. So I know I cannot use the postulate because I'm not given any angles. Let's find angle R first. So I'm going to put theta on angle R, and I'm going to see which trigonometric ratio I need to use. So I know that I'm given the opposite side and the hypotenuse, so that means I need to use sine. So I'm going to use the inverse trigonometric ratio, sine. I don't know what theta is, so I'm going to put theta, which is what I need to solve for. The opposite side is 5, and the adjacent side is 13. So to find out what theta is, I've got to use the inverse trigonometric ratio. So in my calculator, I'm going to press shift, sine, 5 over 13, and I press equals, and that tells me that angle R equals 23 degrees if I round to the nearest degree. Next, let's find angle G. So if I know angle R equals 23 degrees, I know one angle, so I can use the postulate that states that the acute angles of a right triangle are complementary. So to find angle G, all I have to do is subtract the acute angle from 90. So I would say 90 subtract angle R, which is 23 degrees, and that would tell me that the measure of angle G is going to equal 67 degrees. So now that I've found both angles, I can find my missing side. So to find the sides, I'm going to use one of these two methods. So to find the sides, what I need to do is I need to use the Pythagorean theorem because I know two sides. So the Pythagorean theorem says a squared plus b squared equals c squared. Remember, c squared is always your hypotenuse, and in this case my hypotenuse is 13. So I would say that 5 squared could be a plus b squared, I don't know it, and the hypotenuse is c, so that's going to be 13 squared. To solve that, I get rid of my exponents. 5 squared is 25 because 5 times 5 is 25, plus b squared equals 13 squared, which is 169. So to solve for b, I've got to subtract 25 from both sides to eliminate the 25 from the right side, and that would leave me b squared equals 144. So to solve for b, I need to take the square root of both sides. So when I take the square root of both sides, that tells me my last side, which is RT, is 12. I finished this problem because I know all three angle measures and I know all three side measures. Let's look at another example. In the next example, I look at the problem and I know that I have one side and one angle measure. Let's find the angle measures first. So I use one of these two methods. I can use a postulate that states that acute angles of a right triangle are complementary because I know that angle R equals 28. So to find the missing angle, angle G, all I've got to do is subtract from 90. So I'd say 90 subtract 28, and that's going to tell me that the measure of angle G is going to equal 62. So now let's go try to find the sides. So now that I know that the measure of both of the angles, I can start trying to find the measure of the sides. So let's find side TR first. Let's put an X here. So if I want to find TR, I'm going to use angle 28 because I know that 28 degrees is given to me and I didn't make a mistake. So I'm going to say, okay, well 8 is opposite, X is adjacent. I can't use the Pythagorean theorem because I don't know two sides. So I've got to use the trigonometric ratio. If I want to compare the opposite side and the adjacent side, that tells me to use the tangent ratio. So I would say tangent, let's let theta be 28, equals 8 over x. So to solve for this, I need to cross multiply. So that's going to give me tangent of 28 times x equals 8. I can't put tangent 28 times x in the calculator, so I need to divide both sides by tangent 28 to eliminate it on the left side. And what do I do to the left side? I have to do to the right side. It eliminates on the left. So to find out what x equals, I've got to divide 8 by tangent 28. And I will put that in my calculator, and my calculator is going to tell me that RT is going to equal 15. So I know the measure of RT. Now what I need to do is I need to find my final side. So to find GR, I can do a couple of things. I could use the Pythagorean theorem since I know two sides, or I could use the trigonometric ratio. If I use the Pythagorean theorem, which is a squared plus b squared equals c squared, I know that c has to be my hypotenuse, which I don't know. So 8 squared plus 15 squared is going to equal c squared. 8 squared is 64. Plus 15 squared is 225. And that's going to equal c squared. So to solve for c squared, I need to combine my terms. So that's going to give me 289 equals c squared. So to find the value of c, I need to take the square root of both sides. And to do that, I'm going to find out that c equals 17. So now that I know the value of c, that completes my process because now I know all three angles and I know all three sides. So I've completely solved for this right triangle. So today what I want you to do is I want you to use GeoGebra to make some triangles and find out, solve the whole triangle. Check your measurements.